I want to talk to you about this problem because, one, there is something that is actually involved that we'll get to later that I'm not going to really talk about right now. So, in fact, with the way I'm going to explain this answer is not 100% correct for what we're going to do later, but for what I want you to understand and what I want you to get, this is the way that you would do it. So first off, this question says, how far has the object depicted in this graph traveled? Well, the first thing you need to ask yourself is, what type of graph is it?
Velocity time graph.
It is a velocity time graph. So, on a velocity time graph, how do we find distance?
Find the area.
We find the area. So, if you just look at it in terms of area, there are two options. You can either A, find the area of this entire trapezoid, which if you know the formula for the area of a trapezoid, it's 1/2 base 1 plus base 2 times the height. If you're like, well, I don't know the area of a trapezoid, that's totally okay. You don't need to know the area of a trapezoid because we have ourselves here a triangle. What's the area of a triangle? 1/2 base times height. What's the base of this triangle? 2. What is the height? The height is 5. All right? So 2 times 5 is 10. Half of that is 5. That's a 5. Yeah, it's a 5. All right? So there's that triangle. We also have this rectangle. Base times height. What's the base of that rectangle? 4. What's the height? 4 times 5 is 20. Okay? And then we have this triangle. Okay? What is the area of that triangle? Base is 4. The height is 5, so that's 20. Half of that is 10. So 5 plus 20 plus 10 is 35, and the unit is meters because it's 35 meters. Make sense?
Yeah.
So on a velocity time graph, how do we find distance?
Find the area.
Area. Okay? So always pay attention as to whether it's a velocity time graph or a displacement time graph or a distance time graph. Okay? All right, so yesterday we talked about, we dealt with velocity time graphs, and you had a velocity time graph that you had your little strips of paper that did that number, right? And what did I tell you to do with those?
Shade it up to 1.
All right, so you told you to shade them in, and let me make this a little bit bigger so you can see it better. Okay, so I told you to shade this in like that. And what is that?
That's the change.
It's my change
Velocity.
in velocity, which, what did I call that yesterday?
Acceleration.
Acceleration. All right? So, change in velocity is acceleration. Now, that's rather important that you get that that's what it is, but let's talk about what that actually means. Let's say for a second that instead of bars of paper, I had little dots, all right? And so we could have our velocity time graph, and it would look something like that, okay? Now, what is constant on that graph? What is constant right here on this graph?
Speed.
The slope is constant, all right? So if my slope is constant, then something is constant, right? Now, I want to remind us about what slope came from. The other day we started off with a distance time graph, right? And if I had a distance time graph, that looked like this. Does this have a constant slope?
Yes.
Yes, it does. What did we say this slope represented? We said it represented speed, and we got that because we have our y is a change in distance, and our x is our change in time. So we had our change in distance over time. And so our slope was our velocity or speed. Okay? Now, this is important as far as your understanding of where we go from there. Understand the reasoning behind this. We have a change in distance giving us a change in time, or over a change in time. That gives us a slope on a distance time graph. And we called that change in distance velocity. Change in distance over time is velocity. Okay? So if I go back to my velocity time graph, if I have a change in velocity over a change in time, what do I have?
Acceleration.
Change in velocity is acceleration. So on a velocity time graph, the slope tells us acceleration. Did everybody see how I got that? Okay, so on a distance time graph, the slope was the change in my y value over time. So on a velocity time graph, the slope is still the change in my y value over time. And my change in y, in this case, change in velocity, is acceleration. So what is constant on this graph? The slope. Therefore, that means we have a constant acceleration. Now, one of the biggest misconceptions and the biggest mistakes students make is thinking that acceleration and velocity are interchangeable. It's so often I have people that it's clear that they don't see that there's a difference between them. Hopefully, based off of the lab that we did yesterday and your little strips of paper, you can see that they are not the same thing. Because your strip of paper represents the velocity. The little shaded part is the acceleration. Those are not the same. Therefore, it's not the same thing. Right? So let's talk about what acceleration actually is. A way I like to talk about acceleration is how fast changes. And that sounds really confusing, but hopefully it'll make sense in just a second. Let's say that I have this first little square here. Let's say it represents traveling 2 meters per second. Okay? Then I travel 4 meters per second. Then this next one is 6 meters per second. Then this next one is 8. That's an 8 meters per second. Okay? If those were the numbers, let's say each one of these is 1 second. That's a second, that's a second, that's a second, that's a second. So each one of those is 1 second. You with me? Okay? So, what is this red part?
Acceleration.
Numerically, based off of what I just wrote down, what is it?
2.
It's 2. Because it's the difference, right? So what is that red part?
2.
And what is that red part?
2.
So what's happening is every second I'm traveling 2 meters per second faster. That's acceleration. It's how fast changes. Every second I'm traveling 2 meters per second faster. So that's an acceleration of 2 meters per second per second. So I would write that as 2 meters per second per second. Every second I'm traveling 2 meters per second faster. I was going 2 meters per second. 1 second later I'm going 4 meters per second. So think about that in terms of you sitting at a stoplight in your car. You're at rest. You're not moving. The light turns green. You hit the gas. 1 second later, you're traveling 5 miles an hour. A second after that, you're traveling 10 miles an hour. A second after that, you're traveling 15 miles an hour. You're accelerating. Every second, you're getting 5 miles an hour faster than you were before. All right? Acceleration is the change in velocity. Okay? We good? So, back to this graph. This is a velocity time graph. If I wanted to find out how far I went, what would I need to do?
Find the area.
Find the area. All right? So, on this graph, does it go through the origin? No. This means I had an initial velocity. My starting velocity was not 0. All right? So my ending velocity is up here. I have a triangle right there. All right? And so to find the distance, I would find that area. The problem is does that give me the whole distance? No, because that's not the whole area. I also have this rectangle down here. I have to find the area all the way down. Okay? So if you start with a value that's not 0, you're going to end up with a triangle, or not a triangle, you're going to end up with a rectangle down here at the bottom, and you have to remember the area of that rectangle affects the total distance traveled. Okay? Cool?
Cool.
All right. Okay, so now we're going to look at what the assignment, we're going to do number 1 and number 2 as example problems so you can see what I mean by when I say show your work. So on your own paper, get the worksheet that I gave you, and we'll start doing the first 2 together. All right, so number 1. Starting from rest and moving in a straight line, a runner achieves a velocity of 7 meters per second in a time of 2 seconds. What is the average acceleration? We're going to solve these problems without doing algebra. I'm not going to give you equations. I'm not going to have you solve it algebraically. So we're going to do it with a graph. And 9 times out of 10, it's going to be easier to solve using a velocity time graph. So I'm going to draw a velocity time graph. When it says starting from rest, what does that mean?
It goes to the origin.
It means my velocity, when time equals 0, my starting velocity is 0. And then it goes to 7 meters per second. And it does that in 2 seconds. So I'm going to plot that point of 2, 7. So my x is 2, my y is 7. And so I have my line. Okay? And it wants to know the acceleration. Based off of what we just talked about, how do we get acceleration on a velocity time graph? That's distance. How do we find acceleration on a velocity time graph? Slope. So I need to find the slope of that line. What is the slope of this line? Well, it's rise over run. My rise is 7. My run is 2. 7 over 2 is 3.5. 3.5 what?
Meters per second.
Meters per second per second. We'll give that a different unit later, but for right now, just meters per second per second. So that's it. All you have to know is distance is area, acceleration is slope, velocity is simply the y-axis. Okay? If you draw a velocity time graph, you can solve most of these problems just by graphing it. Cool?
Cool.
Let's look at number 2. Okay? Number 2 says, starting from rest, a car accelerates at a rate of 4.2 meters per second for a time of 5 seconds. What is its velocity at the end of this time? Well, I'm going to draw my velocity time graph. How does it start? Starts from rest. So I'm going to start out at 0. Okay? Now, this time it says the acceleration is 4.2 meters per second. Acceleration is the
Change in velocity.
okay, so on the graph it is the slope. So what this means is if I have a 4.2 meters per second, what that means is I have a slope of 4.2 over 1. So I have a rise of 4.2 and a run of 1. So then I'm going to do a rise of 4.2 again. What's 4.2 plus 4.2? So at 8.4, I'm at 2. And so I draw another point. And then I do it again. All right, so that's going to go up 4.2, so I'm at 12.6 at 3 seconds. Each second I go up by 4.2. So at 4 seconds, I'm at 16.8. And so at 5 seconds, I'm at 21. 16.8 plus 4.2 is 21. Okay? So, what does the question ask?
What is the velocity at the end of the time?
So the end of my time is 5 seconds. My velocity at 5 seconds is 21. So my answer is 21 meters per second. The rest of these problems are basically like that. You just graph it and you read you're finding either area, slope, or the y-axis. Okay? Any questions before we go on? So we go on and complete the rest of the assignment on your own. Have fun.